Hello, hello, hello. Good morning, good evening, wherever you are. Welcome to Kubernetes and Enterprise Guide, third edition labs, I guess we call these things. My name is Mark Borstein, CTO at Trello Security, and my infamous co-author, Scott Surovich. Scott, how you doing today?
I am good. Mark, how about yourself overall?
Just another day in paradise.
Life of IT people.
Yeah, my lab MySQL died, and it's giving me problems trying to recover it. And of course, I don't have a good backup system in place yet, and that is entirely on me. But hey, and of course, I have no need to fear because Boris is in fact here. How you doing, Boris? Welcome to the party. I'm glad you're on time because we weren't. Um,
We're on time for us. It's okay.
for us,
Right?
yeah,
Good.
yeah. Um, so last week, oh, there goes Scott. Uh-oh. Wonder where Scott went. See if he knows he's gone. See here. Oh, there he is. He's back. Just about to text you and be like, "Where'd you go?"
Apologies. I actually was trying to log into the chat at the same time so I could put something. And when you clicked on login, it took me to the SteamYard. It kicked me out of everything. And I'm like, okay, you know what? Don't click that button. I just wanted to, comment to people like, Boris and that. And
yeah.
I'm not going to.
So last week we started what chapter are we on? 15, I think. Yeah, monitoring, and we did Prometheus, Grafana, and Alert Manager. So, what metrics are there, and what are what's your cluster telling you from that standpoint? This week we're going to see what our pods are talking about. Like, what are our pods saying to us? Are we listening? Are we using our listening when it comes to our pods? Yes, I do have kids in elementary school. Why do you ask? And so, logs, right? And one of the crazy thing about logs in the Kubernetes world is when we went from VMs to pods, VMs, we would break up our logs. Like we would have an access log, we have an error log, we'd have all these different logs. And then Kubernetes came around and it was just like, no, throw them all standard out, be done with all that nonsense. No more log management for you.
Well, wait, there's one separation, right, Mark? Standard out is one, sure, but there's also error.
But those still go to the same place. Like you don't.
You could. We actually have some systems we send them to different indexes.
Okay.
Right, but
and we're going to get to that in a second. I do want to talk about, but what I'm going to do is instead of our usual, we're going to talk for a few minutes, then kick off the labs. I'm actually going to kick off the lab first because these labs just run for a long time before you can actually do anything with them. So we'll kick off the lab. We'll talk during then. And what we're doing, so we're in chapter 15, and this is the second section, starts on page 464, log management, in Kubernetes. And we use something called, Boris, I'm sorry.
We're losing Boris. It happens.
Not forgiven at all. Not getting a birthday present for me this year. But as always, we'll see you later, Boris.
Yep.
So we use OpenSearch in the Speaks Lab. OpenSearch is a project from Amazon that was forked from Elasticsearch. So it was what was once called the Elk Stack. So it was Elasticsearch, Logstash, and Kibana. Elasticsearch is time series database. Logstash is how you can get logs from something into the time series database. And Kibana is a web UI for the whole thing. And there was some, shall we say, disagreements between Amazon and the company Search. And we're not going to dive too deep into those. There's plenty of Google on that. And we don't take any stance on that. It just is. And so Amazon forked versions of those projects and created the OpenSearch project, which is an amalgamation of those three things together and all integrated. And so so we went with OpenSearch in this lab for a couple of reasons over the Elk Stack. There's another open source log management tool called Graylog, which is extremely popular and very capable. I've used it in labs. I've never used it in production. Bonjour, Kafka, our friend. Good to see you. Thank you for coming as always. Short notice. We didn't go with Graylog or Elk because both of those hide their SSO capabilities behind paywalls. And while I am not going to get into my opinions on that about hiding OIDC, I get why they do it. We wanted to be able to show, this is an enterprise book. We wanted to show what things look like in enterprise and part of that is SSO. So we decided to go with the OpenSearch stack. So I'm actually going to go straight into the lab so that way it can go ahead and start running while we're going. So I've already got my cluster created. Now, I went ahead and started with a fresh cluster. I will say this lab requires horsepower. I was running at 24 gig on this VM. I had problems yesterday. I boosted it to 32 gig. That's because you're running the entire OpenSearch setup in a single VM. In the real world, it's probably expecting to see it running over multiple nodes. But we wanted to keep this simple. So you are going to need a beefy VM to run this particular lab. So I'm on page 465. So first thing we're going to do is we deployed our cluster. So now we're going to deploy Prometheus. So the reason why we're deploying Prometheus again is because, where the heck am I? There are some CRDs that OpenSearch relies upon. So we're going to go ahead and deploy the charts again. Now, in theory, if you are running through this and you started off at the beginning of the lab, you could probably skip this part. It's been a while since we wrote this chapter. I suspect I ended up redeploying this because I probably had to reboot the machine several times, and these kind clusters generally don't survive a reboot. All right, so deploy Open Unison. So now we're going to deploy Open Unison. Reason why we're deploying Open Unison is we're going to integrate Open Unison with OpenSearch for SSO. So this one takes a minute. So one of the things that I always like, log management in Kubernetes was always like storage to me almost, in that I always imagined there was this crazy API or whatever that things were getting. No, it's all just getting piped to files, and then there's this other system that tails it. And like that's log management in Kubernetes. Like that just realization for some reason is not what I was expecting.
Well, probably important too to point out, right, Mark, that's I'm going to say the best case scenario, because what if you have an app? I'll ask you this question since you're doing this. You have an app that doesn't go to standard out, right? You got some config, and some people don't know this, right? They'll containerize something, and it's still going to create potentially a bunch of other log files.
Yeah.
I mean, hopefully you know your apps enough, or else you're going to miss some of that. Now, missing it's one thing, right? Missing that data, but more concerning to me is how that fills up the file system. And of course, anybody watching, your ephemeral file system gets to 79.99% by default. You hit 80, you start getting evictions.
Yep.
So be careful on that. That's ephemeral space that goes onto the underlay overlay, and yeah, you got to be careful.
Yeah, it's and as an app developer, that was one of the things that always drove me nuts because we have all these logging frameworks, right? That rotate logs. You don't want too many logs. How often do the logs rotate? Do you split them up amongst multiple logs because they have different functions? And then you get to Kubernetes and it's just like standard out. Everything goes to standard out.
Yep.
That's it. Let the log management system sort it out on the other end. Um, and so that part was always kind of crazy to me. Was this like, oh, we used to spend all this time building and like tailoring the way that logs got managed. We need to go back to everything goes to one log file. And I just that was always very strange to me.
Well, then this calls into question too, Mark, on some of these systems that people may not know. So we're doing it with some native Kubernetes tools. I'm going to say, I shouldn't say native,
real quick, Scott.
Yeah.
Just going to pause you right there. Open Unison is deployed. So the last kind of active part of this lab is we're going to go up to OpenSearch, and we're going to deploy OpenSearch, and we're going to talk about these scripts in a second. But I'm just going to kick this off because while the OpenSearch install itself doesn't take very long, the and OpenSearch CP. Kube
Namespace.
namespace, yeah, kube control, get pods, and open search CP.
Yeah, so you had it right, I think, in that. Yeah, it was spelled right.
Operator. Okay, so this thing's just, there we go.
There
All
we
right,
go.
so we're just going to throw this on a watch. This part takes a while. So Scott, go back to, I'm sorry I interrupted, go back to.
No, absolutely, Mark. It's so as you get, you got to worry about if you're thinking about external logging systems. If they pull, which most do, but let's say you might not, Kubernetes metadata, right? Because there's systems out there that if you're going to forward, heck, I'm going to use OTel for an example, right? Depending how you deploy OTel, you can actually miss metadata from Kubernetes, which means you get a bunch of log files with no information that is discernible to kind of go through your logs efficiently. Could be namespaces aren't in the metadata. So you've got this, a bunch of stuff, but you don't know what it correlates to. So
Right.
again, keep that in mind. There's multiple ways. Now there's easy ways to deploy things too. Mark mentioned earlier how we needed a lot of memory in this case. Depending how you deploy some deployments, let's say you got a 100-node cluster, not huge, right? I mean, it's a big cluster, but if you deployed OpenTelemetry in a daemon set, by default, just you grabbed it from Git deployed, and I've seen this happen. You kill your API server.
Yeah.
It's just going to hammer it trying to get stats. And when I say kill, good luck trying to delete the OTel deployment now because you can't issue a kube control delete.
Oops.
You can try. Personally ran into this. I had to run a script that constantly tried it. Eventually one got through. And when it got through, cluster was back. Right, so just gotta be careful. I tell people these downloads from Git are cool in a lab.
Yeah.
But man, you go to a prod, they are not optimized.
Yeah.
Rarely are they optimized, right?
No, well, it's almost impossible to optimize for a production environment that you don't
generic.
know.
Yeah.
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 So we are running on. So the Kubernetes is kind. It's a single VM, and then the VM is running on Proxmox. It's just this takes a long time for all of the indexes to get up and running, and I mean this could take 10 minutes before we're able to actually interact with our OpenSearch. So yeah, this will take a while, and we can see it's starting to kind of move around. We got one master, we got the node going, so slow and steady, we'll get there. So fun fact, before Splunk was a thing, and before these log aggregators were all a thing, I actually wrote one. I almost ended up founding a company or co-founding a company to do it. We were I was working with some friends that had been a former customer, and they had this idea of building this thing that would take all these logs and dump them into a relational database. Time series databases weren't a thing back then. Like they weren't super popular. They probably existed, but they weren't. Um, they weren't as big of a thing. And we got the initial prototype working, and this was a very big household company. Like this was a company that everybody on this listening to this anywhere would have heard of, that they were working for at the time. And we were running into scaling issues because of the relational database. Relational database just didn't scale to be able to handle the amount of logs. So we ended up abandoning the process. Like a year later, Splunk came out. Like, wow, we really should have figured out that whole time series database thing. But it's when you get into the architecture of the way these systems work, and I'm gonna pull up this here. So this is the picture from the book of the way it integrates. And so OpenSearch, it's a client server setup where every single OpenSearch itself runs as 3 backends, right? You've got master nodes, that's your data storage. Then you've got front end nodes, host the API. And then you have Kibana, which is your actual front end, right? The way you get logs in is you need to use something to call the APIs. So in the original Elk stack, it was a system called Logstash. There was another system called FluentD that seems to have kind of taken over for a while Logstash. We actually went with FluentBit in this deployment. When you dig down into the deployment, we went with FluentBit, and the big difference between at least FluentBit and FluentD is FluentD gives you the opportunity to do a lot of manipulations with the logs before it goes off to the API that you're forwarding it to. Whereas FluentBit, you just nope, get the logs out. Not my problem. Get the logs out. Just go. And it's much lighter weight. Like the FluentD was like a couple of gigs of memory per node, whereas FluentBit was like a couple hundred megs. And so we ended up, and it was a much simpler implementation. So we ended up going with that. The interesting thing, though, is that FluentBit is a daemon set, right? Because it needs access to all the log files that are getting generated by all these pods. So you gotta be careful because it's now a privileged container because it has host file system access.
Yep.
So you gotta be careful about that one. Make sure, but that's how Kubernetes gets those logs. Your pod generates a log file that's standard out and standard error go to, and then your daemon set watches these log files. And then as the log data comes in, forwards it off to the node via the API, which then stores it into the master. So that's from a generic standpoint how all of these systems are going to work, whether we're talking about OpenSearch, Kibana, or OpenSearch, Elk, Graylog, Splunk. What are some of the Splunk? What are some of the other proprietary?
Wow, to collect logs. A lot of them are starting to base off of a derivative of OTel anyways, Mark.
Really?
Right? So even Splunk, but I hate saying that because Splunk heavily optimizes the OTel that they have. Right? They've got some I want to say proprietary information there. Because again, as I just mentioned, when you deploy an OTel, you might kill the API server. You got to do stuff more efficiently.
Right.
And they've done that in their configs. So that's why it says OTel, but it's based. I like hearing that,
Gotcha.
so they tend to take the open source, do some things. But of course, there's, Dynatrace, Sysdig, right? Sysdig Secure out there. And I think even a lot of them, I know they all tend to work with OTel, right? That's a very common thing now, knowing, hey, yeah, you might be doing OTel for a lot of things. We're going to work with that system, because you're going to hear that a lot in the enterprise world.
Right.
Just
Right.
because it is pretty easy. It's I shouldn't say it's easy. We talked about this last week, right? Logging and monitoring is a skill set.
Yep.
Right? To me, it's an engineering, just like an MCSE, ESC, anything else. It is. There should be an entire, 7 test certification, because sure, anybody can deploy one, but it's not optimized.
Right.
And then let's forget about how to massage the data. Right? That's a whole another skill set of correlate this, and this, and this. Of course, that's where AI comes in. And I'm going to talk about that in one of our upcoming side, discussions. Got a very cool thing I'm working on to show.
Yeah, I mean, and one of the things that is actually really interesting to me is we don't talk a lot about cloud deployments here, but I run a few clusters in the cloud, and the log management can be almost as expensive as the cluster.
Yep.
Like if you've got regulatory things that say you need to keep logs for 30, 60, 90 days, whatever, that log management gets expensive fast. It's crazy how expensive.
It's all part of that hidden cost, right, Mark? Everybody likes to look at the
Yeah.
charts and go, what's my compute engine going to cost me, or what's my Kubernetes going to cost me? And they forget about everything else.
The log management is often as expensive as the compute. And I will say it's almost useless because it's so difficult to leverage. You gotta learn these custom query languages, and one of the things I like about the setup we're going to dive into here is it actually the data that goes in includes metadata. So you're not just searching the logs, but it's got tags for things like what namespace and what pod it came from.
Kind of what I was going back to when you were doing the lab, Mark, right? Was saying that it's there, but not all systems pull it. This does.
Right.
But, and most do that are Kubernetes aware, but some less than others. And I don't want to get into that conversation, because we're not here to talk about vendors, but there's just some that are more native Kubernetes and knows that metadata than others. And there's actually some big names you wouldn't think of miss some of that.
Yeah, which is one of the reasons why I like OpenSearch is out of the box. It just works with Kubernetes pretty well. Now we're not going to really dive into the specifics of how to get OpenSearch, like how to productionize OpenSearch. There are plenty of books on it. There's plenty of material. It's a complicated system that has earned its own book. There's plenty to know there. The point here is to show how Kubernetes manages logs, right? So we now have a working OpenSearch. We can see everything is running. And if we go to, let's first look at what the logs look like. So I am on page. I also don't know how to use a keyboard. Oh, it's because I'm clicking on I always do this. I've got the screen that I do my work on, but I'm looking at the screen that I'm the actual live stream. I'm like, why is this not? Oh, right, because I'm in the wrong place. So I'm on page 467. Let's go ahead and clear this out. So kube control get pods and bit. All right, so we're going to do kube control logs, fluent bit. And we're going to do know this. So this is the Fluent Bit daemon set. This is the thing that actually pulls the logs off of individual nodes inside of our cluster. So if we look for our Nginx, we'll see here, that we've got logs from multiple pods, right? So each of our pods running on the node generates a log, right? So we've got kube control, get pods, and ingress Nginx, right? So we've got admission create. There's our admission create log, right? That's the log that got generated by admission create. We've got our patch, which does something. I don't know what, doesn't really matter, but patch. And then we have our actual controller. And so now we have a controller log. So Fluent Bit is getting the metadata from Kubernetes, say, hey, let's go look for where the logs are and tail them. It's a fancy tailf. I mean, there's a little bit more to it, but it's basically a tailf. And so that's where the data is coming from. Fluent Bit takes that data, pushes it off to OpenSearch, the OpenSearch node. And then it's up to the OpenSearch node to then store that into the OpenSearch time series database. All right, so let's go ahead and get to the fun part where we actually start messing with our logs.
So Mark, I'm curious on that. That's a daemon set, right?
Yep.
We have two nodes. We've got a control plane node and a worker node in our cluster. So I'm guessing the daemon set doesn't have a toleration for the control plane.
That's a good question.
I'm guessing by default, because the reason I bring that up is then you wouldn't be getting some of your API data. Well, you might get API because that's going to be listed elsewhere, but you're not going to get some information like your audit logs. Although that goes to a different section anyway. So it might be a bad example to even bring up, but I thought it might be.
I feel like it does have.
Yeah, you don't want to configure that differently anyways because your audit logs are standard out, but you could use Fluent Bit to grab secure log and forward it somewhere else. But that's a different config, probably more of a sidecar.
So we are now logged into OpenSearch. And I gotta say, I think OpenSearch has a really nice, pretty UI. And one of the things that I think is really cool is I'm logged in as most, right? So we've got the SSO set up. So that's scripted, all the SSO set up. We're not going to dive too deep into that. But you can take a look at that script and see. Well, maybe we'll get the script. These things are actually going a little faster than I thought they would. All right, so we are now on page 470. So we're going to go to over here to our little triple dots. And we're going to go to management, dashboard management. All right. And then we're going to click on index patterns. And we're going to create an index pattern. And we're going to use log stash star. Copy it from here. So we're on page 471. And we can even see that it's season index, right? Log stash from today. And then we're going to click next step. And then you got to pick a time field because it's a time series database, right? So it's got to figure that out. So we go with @timestamp. And then it looks, right? And it figures out all the different metadata fields that are available, right? And you can see there's like 20 pages. And cluster namespace. So all sorts of data. We've got all the Kubernetes annotations that are available, right? So it's going through and it's figuring out all the data that's available. And that's big, right? Like it's not just a matter of here's the data, but here's all the additional metadata, right, about the log information. So like if we wanted to turn this into a multi-tenant system, where you had to have ownership of a namespace, that metadata is there, right? That we can say, no, we're only going to limit you to these namespaces. I don't know how to do that off the top of my head in OpenSearch, but at least the metadata is there, right? All right, so we did that. Oops, where's my cursor? Here we go. Any referencing? So this is out of chapter 15 from the book. So what we do when we go through the labs is we're actually walking through the book itself. So you're free to run the labs. The labs are all in GitHub in the book's GitHub, but we're referencing the labs inside of the book. So I did that. So now list of all the fields. We haven't created a visualization, so let's go ahead and do that. So we're going to go to so I'm on page 472. We're going to go to Event Explorer. Let's see here. Oh, no. Wait, what do we do? Oh, observability log. See, this is where GUIs get a little cray-cray. All right, so we go to logs and we go to Event Explorer. And so OpenSearch has its own query language. Again, we don't really dive into what that means. Always, we do some very basic stuff. But we're going to go ahead, put in that, and we're going to say the last 15 hours. Get easy and run update. I had this yesterday. What did I do wrong? Set the index pattern. I did something wrong. Source. Let's try that. There we go. Okay. So lots of data here, right? More information than what we know what to do with, right? That's just too much. So let's go ahead and look for something more specific. We're going to look for stuff coming out of Nginx. So you can see here this like, can I make this bigger? No. All right. So here's the query. So we're saying we want to get from anything where it's Logstash, where the Kubernetes namespace name is Nginx, and we want the log. So now we can actually see here, this is the information coming out of Ingress Nginx. That's kind of small. Can I make this go away? No. All right. We're kind of stuck with it. But as you can see, we've got all sorts of information in there. If we want to do a different namespace, let's say we want to do the Open Unison namespace. And now we've got pods coming from, did that actually do what I wanted? Oh, that's annoying. All right, let's make that smaller. Open Unison, refresh. Did that work? Maybe not. Open Ingress Nginx. Maybe I'd only configured it to work in Ingress Nginx. But you can see we got session checks, all the different stuff in here. So again, this is not meant to be a comprehensive, here's how you use OpenSearch, right? Because it's a complicated tool that you can spend a lot of time with. But just kind of the basics, you can see how it fits, how it's coming together. We actually made it through this a lot faster than I thought we would, because I think that's the end of the labs. Yeah.
Admittedly, ChatGPT is really good for helping you make queries.
Oh yeah, definitely.
It's one of the I'm going to say, I hate to say a few things that's pretty accurate with, but that's a really concrete kind of thing to give you. Because I do tend to forget the queries as well. Plus, I do work a lot of different systems, right? All the cloud providers, even on-prem, I'll work in probably 5 different ones, right? So you forget because none of us use the same one.
Yeah.
It's just always going, oh man, I tend to use other queries and then go from there. And some of the nicer systems obviously have some autocomplete, right?
Right.
Type it in and it finds it. I often like to take dashboards that already exist and then take them apart.
Well, and I think doesn't Datadog have an English query?
Datadog's got some stuff in it, and what a lot of them are doing now, to be honest, they're AI. If you were to look at it under the covers, like Dynatrace even, you type it in English, and it's going to convert it for you.
Right. So you don't have to know the query language.
Yeah, give me a report with pods equals to this in this namespace that are, I don't know, failing.
Right.
And it'll go through and basically give you a dashboard, and it's converting what you need to their query language.
Yep. Yeah, and I think, and you brought this up earlier. This is kind of an area where AI super helpful,
especially with different systems.
Yeah.
Right, in these logs. So, what I would hope to do and what I want to show in the excursion is going to be similar to what you already have here, Mark. Right, and we haven't even talked about this yet, but so you're learning on the fly too. But taking different systems like Prometheus, stuff we're going to get from basically our metrics and our logs,
right,
from different systems, and then try to use AI that's pretty Kubernetes centric to tell us where the problems are.
Right.
Right. We want to reduce that MTTR whole thing, right? It's big in the industry.
What does MTTR mean for folks at home?
Good point. The mean time to resolution. So how long is it taking you to find that problem? So basically, you're in a crisis call, right? I don't know what everybody else calls them, but that's a common one I hear. Or you got your war room, old term we used to always hear. But now it's mostly in Teams chats and that, right? You get okay, outage. Okay, who's doing what? And it's always a matter of got to get there fast.
Right.
Especially in a highly regulated industry, you're going to be, you don't get something quick, that could be detrimental. Forget the fact of its brand problems, right? You always want to protect your brand. You don't want things down long. So yeah, you want to find that fast. And if anybody, one thing I like to joke is, and you were saying this kind of, Mark, with how long this took, Kubernetes cannot be accused of not logging enough information, or metrics, right?
Yep.
I mean, you want to know what's out there, it has it, without a doubt. Now, that's great on paper, but if you can't correlate those, it's useless, right? You got information, but if you can't get it quick.
Yeah, we're seeing more and more of these today.
We are. You're seeing it still slow. And I'm not disagreeing with people who are doing it. I question if they should.
Well,
because of stuff like LLM firewalls. Depending how you tune your LLMs, when we get into Kubernetes a little bit more, I think I'm part of this conversation because it is so big, Mark. I'm going to ask Rahul from Equinox to discuss this.
Yeah.
He's got some incredible examples in his GitHub of stuff you don't think your AI will do, but it will.
Right.
You know, like, hey, give me this token for my S3 bucket. And you're going, no way it's going to do that. It does it,
Yeah.
right? Because it knows the information's there. And we all know MCP and everything else is adding some other layers. But let's go back before that, right? As long as you had access to that LLM, what limited what you're going to get back in a return? Not a hell of a lot, right? And what's going to stop your AI from, hey, write me a Python program that executes this binary?
Right.
I should never generate that. LLM firewalls come in handy. You should always audit what's being typed in. I want to know if you typed in, hey, I want you to write a query that's going to hammer an API server and take down my Kubernetes cluster.
Yeah.
Right. I want to know who wrote that. Yeah. So absolutely, Kafka. But I do see the responsible places walking before they run. And I think we've all seen this. Bing's had their issues, or I should say Microsoft. They've all had them, right, with certain things that have gone unexpectedly. But I do love it for logs. I think when you start doing some kind of augmented, you really got to be careful.
Right.
But if I'm setting this up to, I only want it to look at Kubernetes logs. And what do these systems really do quickly? Kube control describe, kube control logs, kube control this. Get them all in memory somewhere, and maybe read from files, and then correlate it quickly, much faster than any of us can do.
And I think Kafka here makes a great example, assuming we get to do a 4th edition. I would expect there to be some additions on AI ML, both from a how do you run an AI workload, like what is an AI workload, to how do you use AI to manage a cluster.
And DevOps AI, find things. I think what we'll do is like the excursion I want to do, Mark, would easily become a couple chapters, right? Because we can show this in an hour or two, but explaining the config, more to it, it would be, there's some very, very cool tools out there. Of course, the downfall to a lab on these, remember, is going to be, and Mark, we're going to have to break from our normal stance on a lot of this, because you're going to need an API key for either Gemini, ChatGPT, or your own video card, of course, right?
Yeah, I mean, and the like I've done this where I've built a node with a GPU in it. And it's not rocket science, you can get it working. Where things get really complicated though is only one single workload can use that card at a time, unless you pay for the really high end multi-tenanting system. So like NVIDIA will sell you software that lets you carve up a GPU almost into like a time sharing system.
Wait, be specific, I think, on what you're saying there, Mark, right? So you passed it through to a VM.
Right.
So it's not one workload, it's one machine, virtual machine.
Yeah, one machine.
Exactly. Right, because you could have 100 pods using that. Because it's
could
just
you
being
have
passed
100
through.
pods using it? I don't.
Yeah, it's just being passed through. So
because when you set up a because when you set up a node with a card in it, the card is recognized as a resource, and so you can only have one scheduled.
Yeah, I can't say I typically don't run my full LLM in Kubernetes. I'll be dead honest. I run it outside of it,
Right?
And I use API calls to it, right? Because are you often going to have people deploying a ton of LLMs on the same host, anyways? That's very inefficient use.
Well, it's not necessarily LLMs, but assuming you're doing a RAG where you've got a vector database, you've got the LLM, you've got the RAG, you've got the vector database, but then you've got your tokenizer. And all three of those things are very GPU centric.
They are.
So, unless you're going to rack up 3 GPUs, which could get expensive, chances are you're going to end up wanting to share those GPUs, and that gets expensive. Being able to carve up the GPUs.
Well, officially in a VMware world, they only support the high-end cards.
Right.
Like you were saying, you can't buy an RTX 5090 even and pass it through. It's officially not supported. You got to have the grid card.
Yep.
Which, like you said, carves it up into big for workstations. People are using these a lot for like CAD.
Yeah.
Right, because you carve it up and get 100 CAD machines all using portions of it. Expensive cards though, like what?
Oh yeah.
$100,000 for something that.
Oh yeah. Well, because they're meant for enterprise, right? Like
Yeah.
they're meant to be,
Always.
they're meant to be deployed into these big metal servers and used across multiple workstations as opposed to having a GPU in every single workstation.
Yeah.
So there's a reason for it. But yeah, no, I think that's a great idea, Kafka, assuming Packet lets us do a second edition, which I mean we'll probably start talking about in the next few months. I mean, about 2 years if we start this summer. That's at least what we've been doing, right? We start in May and we try and take about 6 months to write it. But we'll be talking about that in the not too. There's a lot of stuff we want to put in the edition. Kubernetes 134, which came out this week.
Yeah.
The authentication configuration is on GA. So being able to support multiple identity providers, we didn't include that in this edition because it was still in alpha. We didn't want to get into that. Now it's GA, so that's definitely something I want to kind of get into.
I want your resources a lot, Mark. Right? We'll have Stormforge on for conversation on this, but GA finally went for vertical pod scaling without restarting.
Oh, that's right. Yeah, that's a new feature. Yeah, we don't spend a lot of time on resource management. We probably should.
Number one of the biggest problems in the industry right now, right? You'll see this everywhere. Is Kubernetes? It's not expensive. It's not cheap either, but it's more expensive than it should be because we are wasting resources. 30-40% on evil requests.
And there's no reason why we shouldn't.
Right? No, we should. We should. Yeah.
I mean, we shouldn't have to waste it because isn't that the beauty of all these APIs? Is they'll tell us kind of what
better optimization. I have a statement I like to use, and it's not necessarily the best, but before Kubernetes and cloud, the infrastructure offer catered to the app, right? How many times in the VM world was somebody telling me I need 32 cores? I'm like, you need one. Okay, fine, though, because we didn't have to think like requests, right? Let's not going to know how those again can really kill you. I tell people now, your app has to cater to the infrastructure. Now, probably not the best way. Probably work.
I was going to say, I don't.
Cater's the wrong word.
That's never a good messaging because
it's not. It's I say work
business.
with because if you don't, though, you're not getting
app developer, systems integrator. Yes.
But if you don't, you're not getting the big features, right? I mean, if you do a request, and people listening here, right, a request on Kubernetes is a reservation. Right. So the second people go crazy on a request, which should be just to turn the lights on, you suddenly can't schedule anymore. So what do you have to do to fix this problem? To scaling out or up. Chances are you're paying a license fee.
Yep.
Something for every core. So next thing you know, you're at 20,000 nodes with 50% of them being just because your resource numbers are too high, and you're paying 50% more in licensing. Yeah, or logging, right? In this case, right? Because everything is logging too. It's So cater's the wrong word on that. So I try to reword it to say work closely with.
Yeah, but yeah, there's a bunch of stuff that I think would go into the 4th edition. I could see at least one chapter on, or at least 2 chapters on AI, right? Like running AI workloads and using AI to better manage your clusters.
Probably 3 chapters because the running would be 1, and probably 2 just between the using it.
Yeah.
For your cluster management. Yeah.
And then, the authentication.
We got to drop chapters then too. So that's the hard part. Is what do you drop?
I don't know. I don't know that I would drop any because I actually that's not true.
What are we going to be, a 1,200-page book when we're done?
Maybe, yeah. I might drop the dashboard chapter, to be honest. I I do love talking about dashboard. They made a lot of changes when they went from 6 to 7 that eliminated a lot of what we talked about in the chapter.
Well,
And
it doesn't
so,
change all that much for reverse proxy idea and stuff, right? Mark, people can reference the old stuff
yeah,
to a point. I
to a
mean,
point, I guess the big benefit of that chapter was talking about how easy it is to deploy the dashboard insecurely,
yeah.
and they learned their lesson right after the Tesla hack. They said, you know what, we're just going to disable these things. You can't do these things.
Well, I said an example from the beginning when I said you download something and deploy it. It's rarely enterprise ready.
Yeah,
It's how to
it's
make it
never.
work
It's
easy.
almost never. Like
Yeah.
unless it's people who like we geared the because and it's also unfair to really ask it a lot of times because the thing is scaling up and scaling down are usually two very different sets of things to do.
Mm-hmm.
And so like this OpenSearch demo, right? In theory, I could have scaled this down to a single node and it would have started faster and used less resources. But if I'm going into production, I would never run it with less than one node, right? Like that's not a great idea. So it's one of those things that just like, yeah, you gotta be really careful in the way that you approach it.
Yeah, absolutely.
And that's tough to do. All right, we're coming up on the top of the hour here.
Yep.
So are we going to start with Istio next week?
Let's aim for that.
Okay.
At
I know
least for
you're
that
going to be
one.
doing some traveling coming up.
Yeah, the week after, I'll be out. I'll be, most likely in the UK for that week. Then we're back. We can do a couple, and then I actually have
Yeah,
vacation, which is I need that. So I'm
yeah,
looking
yeah.
forward to that one.
I can understand that. And yeah, let's work on we're going to plan on Istio for next week.
Yep.
Or at least starting Istio. We've got 2 Istio chapters. The first one is on the infrastructure of Istio,
And an
getting it
overview
up
of
and
it in
running,
general. Yeah.
building it, getting it set up. The second chapter is on building applications that sit in Istio, right? That will, how do you authenticate JOTs? How do you generate JOTs? How do you do authorizations? Stuff like that. So we break that up into two different chapters, and then home stretch, kind of building a platform.
Probably
Right,
before
taking
that,
all these
Mark,
things
maybe take a
together.
small break and get into the at the very least, maybe the Storm Forge. We got to get back to the Kube armor. That's my fault.
We gotta get back to Kubarmer.
But that's going to be probably a 2-3 week thing when we're done with
Yeah,
guest speakers and other features. Yeah, and then I want to get some of those in there, and then we could probably go to the end of the year with all of this.
oh yeah, easy.
Yeah.
Well, and also remember we're coming into, yeah, we're fall is always, you got a lot of religious holidays in the fall.
Or
You got a
vacation
lot,
time people don't use that they have
yeah.
to suddenly use. That I fall into that every year.
We got conferences like I think
Oh, yeah.
actually next week is it next the week is 16th. The 16th is Tuesday. Okay, so that works. Um,
Of course, that depends on how my surgery goes. If I have to have one
oof,
for my
uh,
tendon, right? So
yeah.
I might find that out
Um,
tomorrow.
so KCD New York, or not KCD New York, KCD DC is next week. Um,
Mm.
so I wanted to make sure it wasn't Wednesday. I was supposed to go to a conference today, and very annoyed by this. So and I have no problem naming and shaming. There's a conference called Identity Week here in DC, and it's a very pay to play conference. So if you are in the government or you're a potential buyer, they'll let you in for free. Otherwise, you've got to pay through the nose. You got to pay to talk. You got to pay to they specifically went out and started asking people in the industry, hey, do you want to present? And we said, okay, here's a thing we're doing here in DC that we think will resonate. They okay, here's the cost to present. Well, why did you come to me to present and then you're telling me to pay? Somebody offered me a free pass to go this week. It's like, okay, cool, I'll go. And I registered, and they're like, no, you don't count for the free pass, even though it's a speaker pass. Only people that are going to spend money get the free pass. Like, okay, I'm out. But yes, I get very salty about those things. But cool. So Kafka, I hope I say this right. Timoteo, I think I said that right. If I didn't, I do apologize. Thank you. And of course, Boris, always. I didn't post this until about 2 hours ago. So anyway, Scott, thank you as always. Everybody else, thank you as always. And we'll see you next week.
Awesome. Thanks, everybody.